Hi, my name is Russ Lakis. I'm a software QA engineer here at OPHIR SPIRICON. Today I'm going to show you how to get started with your BeamGage system. Today we're going to focus on a BeamGage standard system using an SP620U camera. It's a 1600 by 1200 USB 2.0 camera, and let's see what's in the box. We have the declaration of conformity for the camera. All of the software and documentation for the product are on this CD. Don't lose this, that's very important. Don't forget to read this notice. This is about your CCD detector and how to care for it. We have some spare ND filters to block out ambient light. A standard to metric adapter for mounting. This is the SP620U camera. There's a ND filter already pre-installed and lens cap. And in the bottom we have a USB cable to connect it to your PC. As we're setting up our optical table, there are a couple important things to remember about your CCD camera. Specifically with the SP620, the detector is very close to the outer casing. So take extra care when removing any filters or lens caps. We also recommend that you hold the camera upside down to remove any filters when you're exposing the detector to ensure that no dust falls inside or onto the detector. Only use compressed air to blow dust off of the detector. Never use your breath. And never leave the detector exposed for any period of time. Now that we've got our optical table all set up, the camera is aligned with the laser. We've got a lens in there to make sure we have a good focal spot. Now let's get our software installed. Going back to the box that we received the camera in, we have our installation CD. When you open up the envelope, you have all the instructions necessary to install it. But it's really quite simple. All we need to do is insert the CD into our CD-ROM. When we insert the CD into our CD-ROM, we will see the SPIRICON software auto install application. If the autoplay on your system is not enabled, browse to your CD-ROM drive and run amplayer.exe. Within the auto installer, we have a lot of different features that we've provided for you, such as our catalog, product manuals, and customer service information. With one click on Software Installer, this is going to install all of the software provided on your CD, depending on which products you purchased. Today we're going to be using BeamGage Standard version 5.5. We're going to see a couple camera drivers install first, and then we're going to see BeamGage. BeamGage does require the .NET Framework 3.5 Service Pack 1. If during installation you're prompted to install any drivers, this is normal. I'm going to click Install there. And then also here for the two different Luminera camera models we support. Then we have the PyroCam 3 camera driver installation. BeamGage also requires the Visual Studio 2005 C++ redistributable, and both of these packages are supplied during the installation time if they're not already on your system. For Windows 7 users, the .NET Framework is already part of your operating system, and you do not need to install it separately. Once the camera drivers are complete, we're going to install BeamGage itself. and that was checking for the redistributable. We're going to click Next, and we're on the README screen. In the README, we always post any of the changes from the previous version, any bugs that we know of and how to work around them, and then any other notes as far as installing and such. We're going to go ahead and click Next. We have our license agreement. Be sure to read that. We're going to click Accept, and then Next, and then Install. Users of Xenix Ziva in-gas cameras will also need to note that there's a CD provided with your camera, and you'll also need to install X-Control from that CD for your camera to work. You're going to see a couple drivers for the power meter install, and then we're all finished. Plug our camera into our PC. Windows will let us know that it's installing the device driver, and also that the installation completed successfully. When we launch BeamGage, we're going to see this splash screen, and it'll update with the status. And after just a few moments, the application will load. Let me adjust my beam here just momentarily. There we go, that looks a lot better. The most prominent thing that we're going to see in BeamGage is the gray bar along the top. This is called the ribbon system. The ribbon system gives the user a unified control scheme. All of the controls are located in the same spot, but this bar changes depending on what the user is trying to do. For example, if we click on one of these tabs along the top, such as beam display, computations, or logging, the entire ribbon updates with the controls relevant to that task. Also on the source tab, we see the different sources that we can use, such as Beam Maker, File Playback Console, or our local detector. In BeamGage Enterprise, we also have the network detector, where we can use our cameras over the network. The next thing is the display windows. The display windows in BeamGage use most of the display space, and you enable or disable windows through the Tools menu on the ribbon. The Tools menu is always present for any of the ribbons. And depending on which topic you're on, such as beam display, you'll have different options available. In this Tools menu, we have 3 different display windows, and we can also disable the ribbon bars to reduce the complexity of the user interface. Right now we're just going to enable the 3D beam display, but we also want to be able to see both the 2D and the 3D at the same time. If we double click this tab, that window will pop off to a floating window. Floating windows are really nice because they can be put anywhere you want, especially on multiple displays. If you have 2, 3, or 4 displays, you can make the BeamGage interface as versatile as you need it to be. Right now, though, we're just going to dock this window. When I grab it and move it around, we can see various anchor points pop up on the screen. If I drag my mouse to one of those anchor points, the highlighted area will shift, and that's where my window will end up. From there, I can resize that docking area however I need. Let's go ahead and we'll also add in a beam stability window below my results over here, using the same manner. The next thing we're going to look at is the status bar. The status bar gives both general information about the status of BeamGage and also specific information about certain features, such as ultracal subtraction, our frame rate, our data collection subscription, and our frame buffer. Users of LBA will notice that the frame buffer looks similar, but we've also provided a more user-friendly way to manipulate the frame buffer. Next, we're going to look at the application menu. It's found by the round button in the top left corner. When clicking that, this gives us the functions to load and save setups, load and save data, export in a variety of file formats, queue print jobs, and then also load any recent setup files that we've used for easy access. The last thing that we want to touch on in BeamGage is the help system. In BeamGage, we've supplied two main help modes that allow beginning users to really get acquainted with your BeamGage system. The first is just help. This is the BeamGage user manual, and it opens up our comprehensive PDF user guide. All sorts of really great information in there. While it does have a lot of information and is long, it is invaluable. One of the great things we can do is actually using the next feature. The next feature is called What's This? LBA users will recognize this. If we click on this button and then click on any feature within the application, we'll actually be taken to the spot in the user guide that corresponds. Now we can read up all about beam stability. And for example, if we click on the file format, then we get taken to the spot in the user guide about file formats, or frame formats, and so on. Let's go ahead and close the 2D beam display. We're going to enable beam profile graphs in both the X and Y axes. And then we also want to chart our beam width results for D4 sigma X and Y. By double-clicking this tab up here, we can pop that display window to a floating window and dock it on the right side. And we'll stick the y-axis on the bottom there. I'm going to do a similar thing on the left-hand side using our result charts. And squish them back down just a little bit so that we can still see all of our enabled results. The next thing we need to do is enable an aperture to restrict the data that's being used to compute the beam widths. The first one we'll use is actually just a display aperture and doesn't actually affect analysis. This allows you to see how big your beam is currently being computed. We're going to use the auto aperture to actually restrict the data being used, and we actually see our beam width aperture is displaying a much more realistic beam width. And we can also use a manual aperture to restrict some of that even further. The auto aperture is really good for beams, especially if they have a shift to them, if they're wandering, things like that, then it'll move with it. In some cases, it does work best to use both apertures. We want to use that manual aperture about 2 times the current width of the beam. Okay, at this point we are collecting fairly close values. This is pretty close to, if you look over here, that's pretty close to the historical numbers for this laser, but still not quite. What we really need is to do a background calibration. We're going to use UltraCal, which is Spiricon's patented background calibration process, and it's pretty easy to use. We'll just do a single click on the button. It starts the process, generates a signal to noise ratio, and then it wants us to block the beam. It automatically takes care of the message and continues the calibration process when we block the beam. And depending on your camera's current frame rate, the calibration will complete very quickly. At this point, our background is calibrated correctly. We can see that in our 1D profiles that our background actually matches the 0 line. There we go. Now it's actually sucked down there. And our beam width aperture is actually tightened up just a little bit more than before. We'll reset our charts to start collecting only the current data. And if we want to, we can enable statistics by enabling it in the results group. We'll enable mean and standard deviation for the power energy group. Now, since the stats, we don't want just any data in there, we need to stop it before we enable the statistics. We're going to set a running window of 16 frames, the size of our current frame buffer. And when we start that, now we're collecting our statistics. Now the last thing, and one of the most important things we're going to do, is actually save the setup. It's very frustrating to go through all the work of configuring BeamGage and then forget it to save your setup. And call it sample. And there we go. You can see up in the title bar that we are now running with sample.bg setup. This concludes this training video. We hope you enjoy using BeamGage.